So today's menu is going to be structs, methods, and constructors. If these are things you're not familiar with, awesome. If you are familiar with them, hopefully I can teach you something relatively new, or at least something useful that you can take away from this and be ready to start putting it into your own games. These are all features that are fairly new to GameMaker, but in a way have been around in some form of programming language in a long time. GameMaker has been really fantastic about updating on a consistent basis and really adding game-changing features like these. So I'm going to be comparing some of these features to things we already have in GameMaker so that hopefully it's easier to understand. But I'm going to show you how to use them, talk about ways that you could use them, and give you some examples in the project we're going to be going through today. Okay, cows. Cows are a great animal. They're my favorite. So we're going to be using cows to talk about how to level up your GameMaker skills. Now, all I've got in this project is a sprite called SPR cows that then has some frames of different cows because we're going to be drawing them and doing things with these different sprites in our game. And it's just a great way to visualize it. And it's kind of a fun way. So first thing we're going to talk about is going to be structs. So I'm going to go ahead. I'm going to create a new script here. And I'm going to name this structs. Then I'm going to go in. I'm going to maximize this field so that we can see everything. And I'm going to delete everything inside of here. Oh. Hold on. Looks like I got a phone call coming through. So let's get back to what we were doing. So structs. Struct itself is not a keyword. So you see this comes up right here, this function, but that's actually because I named this script structs. Struct itself is not a function like constructor is. Later on, we're going to be talking about it. This has struct in it, but struct itself is not a keyword. So the way you do them, the way you create them, is actually storing them and creating a variable. So your variable just has to be a variable like any you would ever create. So I could actually call this a struct, but in this case, I'm going to call it a cow. And this is the syntax for creating a new struct. You say cow equals open and close curly braces, semicolon at the end. This is a struct. At this point, it doesn't do anything. It doesn't even hold any data, but this is a struct. There are ways and functions that you can come in here and you can say, what type of data is this variable? And it will actually return that it is a struct, not a string, not a Boolean, not an integer. So this is how you create one. Now we're going to open this up so we can actually do something with this. And I'm going to compare structs to arrays. So we've got this here, and I'm going to call this one here cow array. And I'm going to open this up very similar to what we're doing with our struct. So if you're familiar with arrays, you know that you can add data inside of them, and you can have any kind of data you want. You separate them with the comma, and each of these that you can then access with an index. So here, cow array index 0 is the value 0 because that's the first thing I put in there. And 1 would be the string cow. So that's just to show you that's arrays, and that's kind of, that's how you access them, that's how you use them. Now, a struct is different in that it doesn't have indices that you have to access. Instead, it is significantly easier because you can actually do everything by name. Now, here's something very important is that the syntax, which means the way you write it, the way you code it, the way you access it, is going to be different than what we've used before. So structs have a different syntax. The different syntax just means, oh, I'm going to show you what right here, actually. So if we want to put a value inside of here, let's say we want our cow struct, which is just a way to hold data right now. Let's say we want this to have a name. We don't use the equal sign. That won't work. We have to use just a colon. So let's say I want this cow's name to be Suzanne. And let's say I'm trying to copy this over here. So let's actually delete the first entry here and put this in as Suzanne. Now, you can immediately start to visualize the difference. A cow struct is a way to hold data just like an array is a way to hold data. And when we access the data in an array, we say cow array indice 0 and we get this value. If we want the value of the name from our struct, we just say cow dot name. And this will actually give us back that name. And we can look at this if we do show debug message cow dot name and we give this a run, it will show up right here. Here is the name that we've got. It's kind of hard to see, it's a little small, but if you try this on your own, you will see that this works. You can access the data inside of a struct by variable name, no longer by index. You no longer have to go through and do things like this, where you'd have to create a macro and you'd say something like name is 0, and then you can access it like cow array name, and then you know where it's at. This is a perfectly valid way of working, and it's not that structs are eliminating that, because structs aren't replacing anything. They are just another way to store data. But in this case, we can access this all by variable name with just typing cow.name. Then if we want to do more things inside of here, we absolutely can. We just need to add a comma, and then we can do more variables, more data, whatever we want. So is this a favorite cow of mine? Yes. Suzanne is one of my favorites. And you can go on and go on forever and ever here. You have as much as you want, and they can store data just like this. Now, the really cool thing is that structs are just a variable. That's all they are, which means that if we wrote a function like, let's say we wanted to set the name of something, we could actually pass in this entire struct, just like we could pass in an array, but then we can actually access this the way we want. So if I wanted to rename the name of this cow, I could do that right here. Now, this isn't going to be called because I'm just in a script right here, but the principle is that you can pass a struct just like you could pass any other variable, because that's what it is. A struct is a variable just holding data in a new format that you might not be familiar with. So that is the fundamentals of what a struct is. Now, there are a few things to point out. I'm going to type the word constructor. I'm going to press F1 to bring up the menu, or to bring up the try and bring up the manual here, but I'm having an issue. So let me try and bring it up from over here. Okay. So there are some variables that you are not allowed to use. So let's go here, click on struct forbidden variables and see if this works. Oh, no, I'm having some issues on that. Okay, cool. So this doc is having an issue, but in essence, you cannot use what is a global built-in variable. So something like game ID, you cannot use this because it is a global built-in variable that can be accessed anywhere, and you're not allowed to do that. You are allowed to use built-in variables that are more local though, which is pretty awesome. So if I wanted to actually store the X value, if I wanted to create a variable called X, you could absolutely do that. And this would be perfectly allowed. And then you could access it like cow.x. Thank you there, Evan, for pointing out that manual. My internet seems, I'm streaming, but I don't seem to have any internet, which doesn't make any sense. So we've got cow.x. This is perfectly valid. This is referring to this variable in this struct. So you can use variables like this. Of course, you can also come in here and call them maybe something more descriptive if that would really help you out there. So structs are a way to hold data. You can hold any kind of data, and structs in essence are just a variable. That's it. You can pass them around, you can change them, you can destroy them, just like you could do anything else. The really great thing is that a struct, you create it once, it takes up a little bit of memory, but then it doesn't use uh, any more memory, any processing power besides that, because it's not an object itself. Structs can be referred to as lightweight objects, but objects in your room actually have a lot of data that are being stored about them. Like if we create an object, call this obj cow, which we're going to use in a little bit, already you can see that this object has to have a sprite, or it can, has a mask, it can be visible, solid, it has all of these events. All of these things are things that GameMaker has to actually keep track of. The X and Y of this object, the sprite index, its image, its speed, all of that GameMaker is keeping track of, but structs allow you to store data in a way that it doesn't have to do that anymore. Now, structs are not a replacement for an object. For your code to be running, your struct needs to be in a script, which then usually gets called inside of an object. Structs are just a way to organize that data in what I think is a much more user-friendly way to be able to access, read, set, and do all of that. But you can also use those as lightweight objects, because you can imagine, instead of, let's jump away from cows for just a minute. If we came down and we wanted to create a struct for an item, let's say that item has a cost. It's 100. Let's say it has a sprite associated with it. Let's just call it SPR sword, and so on and so forth. You can fill up an entire struct with this and then pass that around different objects. So if we had an inventory we were trying to create, we could do that. If we wanted to have a field full of cows that were all different and in different locations, we could do that with structs, and by just having one or two different objects inside of there. So structs do not replace anything, but there are a lot of reasons to use them over other data structures like arrays or maps, depending on the situation. So let's jump back into the Q&A. I'm going to jump in. I will put Q&A on. So if you have any questions about structs, remember, we're going to cover methods and we're going to cover constructors next, or we're going to cover methods and then constructors. So does anyone have any questions about structs or anything that I covered there? First question comes, let me go ahead and pop that up. So Luis asks, can you use functions in structs? And the question, and yes, that's actually what we're going to cover next. Methods or functions, they're a little bit different, but methods are a way to use functions inside of structs that then allow you to call those from other objects. And we're going to cover that in just a little bit. Thomas asks, construct contains more than one value that has the same property. Constructs contain more than one value that has the same property. So you're talking like if I wanted to have another thing called X position, you're going to run into the problem just like any other data, or just like an object would. So no, this is going to just overwrite this value from up here. You cannot have the same variable name and have it have two different values. In an array, you can't either, but I guess technically if you wanted to have 0th index and the first index hold the same value, there would be ways to do that. But in a struct, no, you cannot do that. I'm not going to try to butcher that name, but we have a question that says how to combine struct with object. So that's what we're going to be looking at with constructors. But a struct is just a data structure. So if I have to add an event into an object, but I could easily create a struct inside of here. And this is now a struct. So I could do whatever I want. I can put whatever data. So if I wanted to set this, I got that sprite and I want to use frame 3 and I want to draw this somewhere on there. This is a struct. Oh, wrong syntax. This is a struct inside of an object. So if we wanted to pass this around, we could, or we can just have this be inside of here. That's totally fine too. Antonis asks, do we need a global.cow, which is the struct I made, in order to be able to use it anywhere? So yes, structs are just a variable, which means they have the same scope level. Now, inside of my script right here, this is happening and this becomes global because it's inside of a script. If we comment, oh, hold on. The Q&A left for a second. So if we take this outside and we go into an object, this struct is now a local instance variable to this object. You can also do this is a local variable now. It was just an instance variable before, but we could also say global dot my cow if we wanted to. So yes, you can take your struct variable and you can turn it to local, you can turn it to an instance level or global level. All of those are totally fine. So again, a struct is just a variable. And this is where I think it takes just a little bit of hammering home, hearing it over and over and over. Because sometimes when I hear a new data structure, I try to think of a whole new way of interpreting how it works. But in this case, a struct is a variable, like an array, that you put data into. So it has all the same properties as every other variable you've ever worked with. Global, local, instance, they're all the same. Hopefully that makes sense. Okay, I'm going to take a look at the next question. We've got audio. I'm going to go back to that question here. So audio and animation can be used in structs. Yes. So Lucian's question is essentially, what can you put into a struct to make, maybe I'm interpreting a little too much, but what can you do to put in here to make it a little more practical? Like, can you play an animation? And the answer is absolutely. Because when we start talking about methods here in just a minute, I'm going to give you some examples of using methods inside of a struct to be able to draw our cows on the screen. And we could absolutely draw them animated. We could absolutely play some sound effects inside of that. That is all doable inside of a struct. Got another question. Oh, clarification. Object cow has construct items, for example. So again, I'm not totally sure what you're referring to here. Let me go back. Oh, okay. Can you combine struct with an object? So no, I'm still not. Clarify one more time. Let me see if I can understand. I want to try to answer as best I can. Alper asks, does this method have any advantages over using enums to enumerate properties by feeding their names into indices? And the answer is it takes a lot less time. As a programmer, my life goal is to be as lazy as possible. So if I have to go in and if I'm creating that array over here that I'm using all of these macros to name things, or I have variables that are holding the values of indices that I want, that's a lot of typing. That's a lot of things to remember. That's a lot of ways for that to go wrong. If you ever need to increase or decrease that array size, that's a lot. So instead, you can just use a struct and you can access everything in there because your array, those indices are just numbers, but those numbers are related to the data. Like if 0 is name, why not just use a struct that says dot name anytime you want to access it? So using your array with your enums, yeah, you can essentially create the same thing. It's just a lot more work, in my opinion. So that's what I would say there. Can we have a struct inside of a struct? This is something, yes. Let me quickly show you that. So you can have as many structs nested inside of here as you want. So if we have a cow struct, let's return to that. Let's say we need to look and see what kind of, if it has any children. So let's come in here. And the syntax for this looks like this. We're creating a new struct. So we're using that colon, and we can have as many as we want. Well, let's actually say, yes, they have children, amount 7. And now we have a struct inside of a struct. So I'm going to quickly show you what that actually looks like. So if I say show debug message just on the cow itself, so on the primary, on the main struct, this is what it's going to do. Down here, it said it starts with children, so it starts on the inner struct, and then it shows that, and then it pops back out and shows the rest of the values up here. And you can have struct nested inside of struct for as much as you want there. If you go too crazy, it might get a little bit difficult, but to access it, it's the same thing. So same way of accessing the first level struct. So if I say cow.children.amount, that is going to get me the value of 7. This is very similar to a 2D array where you could say something like cow 0, 1, but it's all named, and it's much easier to remember because if we wanted to have a 2D array with enums or macros for names, that just, whew, that's going to get so unwieldy so fast. All right, I got time for a few more questions, and then we're going to jump into methods. So Gabriel asks, can a struct contain a function? Yes, it can. We're going to talk about it in just a minute. Tony asks, can you create an array of structs? Absolutely. An array can hold any data, and a cow, a struct, sorry, I'm talking about cows so much. A struct is a piece of data, just like a string, just like an integer. It's a variable. So yeah, you can have an array of structs. Absolutely. And that's a great way to put them together, and then you can start doing even more powerful stuff. We got another question. If I pass another variable to a struct value, is it copied to the struct or will be accessed by reference? I am going to pass that on to one of the GameMaker supports who will know specifically. Last question. Can structs be a schema for instances which are variants? Okay, Joseph, I have in my head what I think you mean, but I'm not totally sure. So you're talking about just like, can structs be a schema? So like a schematic for instances which are variants. So if you just had one object with a struct in there that you set to have lots of different variables, like if I wanted to have my obj cow, if I wanted this object to have one struct, but I wanted to have, let's say, 1,000 different instances of this object in my game, you could absolutely go in and change the value of every single struct inside of those instances. Because again, a struct is a variable that just holds values. So if you can change any other variable while a game is running or while you're editing the code, you can change a struct. Okay, so let's jump into methods, because a lot of you were asking the question, can you use functions inside of a struct? And this, I think, is where they really start to shine. This is where it gets a much more interesting. So, can we use a function? Yes. The specific kind of function I'm going to show you here is called a method. So I'm going to come down here. I am in my cow struct, which is still in my script. We're going to move this here maybe in just a little bit. But when we want to create a function in a struct, we can use a method, which is, again, it's a variable. So a method is a variable, but it actually holds a function. So instead of this variable holding the number 10 or a word or a Boolean value, instead it's actually holding an entire function. So let's take a look at, well, at a practical example here. So if I wanted to create a function, I could say draw cow equals function. We're going to put an X and a Y position inside of here. And this, oh, got to make sure we use the proper syntax for what we're doing inside of a struct. So this becomes a function. And if I said I wanted to draw a sprite, SPR cows, let's do the 0th frame. We're going to draw an X and Y. This is now a method function, which is different than a runtime function. You can see that it is actually still blue, so it's a little different. I'm going to go ahead and cut this entire thing out, though, and we're going to put it into our object. So I'm going to go back into my object because this is where we want this code to be running from. So when we do this, this struct is now a instance variable in this object. This method function, is now an instance variable inside of this struct, and we can call it just like we can access all of these. So I'm going to add an event, the draw event, because I actually want to use this method in here. And I'm going to say cow dot draw cow. And if I open this up, well, it's a little different because it doesn't actually have anything right here. It's not telling me it needs anything. It is a method and it is a function, so we can call it. If we pass in our X and Y, this will work. But what I will say, you might want to use a JS doc comment called @func, and there's actually quite a few you can do here. But if you do this, save it. Oh, I gotta add a space in between, I think. If we do this, we can actually turn this into an orange method here, which kind of makes it easier because when we come in here, it'll actually show that it takes some arguments, which is really nice. So I'm missing the exact syntax here. I'll see if I can find that in a second. But let's go in. Let's make sure that our object is in our level. And let's give this a run. So when we run this, we now have a cow being drawn by a struct inside of our level. So that gives us, well, that gives us all the power in the world, because essentially what we can go and do now is anything that we want to do, we can actually start kind of creating our own events, and we can make our own functions, and we can pass things into here. And I mean, there's nothing you really can't do at this point. So I might be getting ahead of myself because seeing that you can add a function into a struct might not be that meaningful just yet. So let's see if we can wrap our heads around this idea, because it's really, really powerful and really awesome. And when we get to constructors in just a little bit, it's even going to compound even more upon itself. So this is a method. It's a function. The two are not interchangeable because the method is the variable itself, and you know what a function is. So a method is a variable that holds that function. And now, if we wanted to, we could actually create a function. We could create our own runtime function inside of here that's like pass cow, and we could call cow. So if this was our own function, we could pass in our struct called cow like this, and we could pass in that struct, and then if this was going to return a cow to another object, or we were going to put that in another instance somewhere, that instance would then have access to all of the methods inside of that struct. So a struct holds data, and a method holds a function. When you mash those two together, you now have the workings of a fairly lightweight object inside of GameMaker. Now, when I say that, what I mean is you still have to have an instance in your room. We can't delete this actual instance or object from our level and expect it to work, because everything is running inside of these instances. but we can start creating lightweight objects in the sense that this cow, this is a struct that we can pass around. We can move it to and fro. We can add our own functions inside of here to start doing anything we want. If we wanted to be able to count the number of clicks on this cow, we could. So let's come in here. Let's start with clicks are 0, and I'm still used to that old syntax. Inside of structs, you got to use that colon. So let's say clicks start at 0, and we wanted to be able to count the clicks. So let's say count clicks is a method, doesn't take any arguments, and we're going to say if point in rectangle. So I'm going to use this function. Point in rectangle is just going to be checking to see if our mouse is inside of the bounding box of the sprite. And what sprite are we checking? Well, we're going to be checking the one that we're actually drawing right here, because this object has no sprite associated with it at all. But we can draw as many as we want. We could have an array full of these cows, and we could be drawing them, and they can all be calling these functions right here. So if I say if point in rectangle, we're checking for the mouse x and mouse y, just the global variable mouse x, mouse y. And I'm going to create a few local variables here really quick. So I'm going to say half width equals sprite get width of SPR cows. Now, the reason I'm doing this is just so that I have less typing inside of here. I'm going to get the bounding box of what we're doing. Oh, hold on. I'm going to get the bounding box of our sprite, left, right, up, and down, and I'm going to use that right here. So I'm going to say x. So we've got, let's see, x minus half width. Then I'm going to enter and come on down to a new line. We're going to say y minus, we need half height here as well. Sprite get height SPR cows divided by 2. So now we have that one. And we can do the same thing. We just got to go x plus half width. And we got to make sure we call these exactly the same. Otherwise, we will have problems. Okay. So if the mouse x and mouse y are inside of this rectangle, and I'm putting in a new if statement simply because this is already a very long if statement. So if we also check that a button was pressed for MB left, then I can access this struct variable by just saying clicks plus equals 1. And how do we know that? Well, I'm going to go ahead and say draw text on where we are, which is going to be our x and our y. And I'm just going to put this underneath the cow, I think around, well, let's put it around 350 and see how that goes. Now, there's a lot here, so let me go through this one more time. This function, and I need to actually draw the text clicks. This function here, I'm drawing the sprite, and then I'm going to draw the amount of clicks that we have. It starts at 0, but I'm also going to call this function count clicks. So I'm going to call this cow.count clicks. So that's going to be listening for, it's basically another event that is going to be triggering whenever I actually click on this. So let's run this, and I have a small feeling this might give me a slight error. So let me quickly check that we've got everything in here where it's supposed to be. And we do right here. So we have a malformed statement. Let me see. Have any of you caught the small error I've got here? I've got a malformed if statement. So I don't want to spend too much time on the debugging aspect. Draw cow is missing its comma. Thank you. Wait. Where at? I'm missing that right there. After the method, you need yes, thank you. Method syntax. It is just slightly different than what we've been using. So every time you add a new method, every time you add a new variable, you've got to have a comma after that. So that's a really great example for what we need right there. Okay. Here is where we run into another problem, but we can solve it pretty easily. So this is giving me a problem on the x and the y coordinates. So here we've got x and y. So the best thing to do would be to actually pass these in as local variables for what we want to do. But it is possible inside of your struct to also go in and say other. And that other would then refer to the instance that has this struct inside of it. So this struct has the ability to access the built-in variable and the built-in data on the object that is calling it. In this case, let's give that a try. So if we put in other here, so this is one method. The preferred method is to pass in your actual arguments right here. But now you can see I grossly overestimated the size of my sprite. But if I click on the cow, it is actually increasing the number of clicks that I've got on here. So this is an object. obj cow is running in the game. It doesn't have a sprite. It has the only data that it has is a struct that we have given it. And it only has a draw event inside of here. Everything else we are doing ourselves from this struct. And this struct we could make global and pass around. We can pass it around and return its value in a function to then have other instances do this same thing. And we could change what it's drawing by just adding in more arguments here. So if we wanted to change and draw a different sprite or a different frame, absolutely. Methods allow you to write your own functions in structs, and you can write anything you want, and then you can call them inside of any event just like that. So that is methods in a nutshell. Let's jump over to the Q&A. Let's do a few questions and see where we're at. So I'm going to scroll down and jump over to the method questions specifically, and then we'll jump into constructors after this. So anyone have, let's see. Okay, so first question I'm looking at here is Antonis. Why am I doing this and not a separate script? The reason is, for one, I'm talking about methods specifically, but the reason is that you can now associate methods and functions with a specific object that you would want. So if we never needed to use this count clicks or this draw cow or whatever function you're writing, you don't need to put it in a runtime function that can then be accessed by other objects. Plus, this actually allows these methods to access the data inside of here by default. So let's say you were building a game all about cows and you wanted to be able to have cows that have abilities. You can have each cow have its full set of data, and then you can just call that cow's method, and that method could do things based on the data inside of it. Whereas a runtime function, you would need to pass in all of this information. A method in a struct allows you to call this, and let's say this cow has 0 clicks, but a more powerful cow or item in your game, if it has more clicks or it has more power, it does something entirely different based on the method that you're calling and based on the data you're accessing inside of that struct. So another question, yeah, Antonis, I think I just answered that one there. So let's take a look. Is this going to be available for watching again? The helpers can make sure, but I believe these are available to access again in the future. So I mentioned something about the /@ function. Those are JS comments. There's a lot of them. You can do things like function. You can do things at arguments so that you can actually have more descriptive arguments. You can also do a description one so that you can actually see that description. If you go into preferences, you can change what you see when you're filling out a function. and those are all JS doc comments. So Antonis also asks, how would I save the struct to an INI file? What would it write in the INI for the save file? So that's something that we didn't talk about, but is definitely worth mentioning. And the fact that structs, if you're familiar with JSON at all, they look very similar. And the beautiful thing that they added along with structs is JSON functions right here. So we have JSON stringify and JSON parse. These two functions allow us to actually save an entire struct really easily with just a function right here, and then you can write that to a file. So this will take a struct, convert it to a JSON file, and then you can use the function JSON parse, and it will parse a JSON file, which is what we just made, and then you can just read it back and it will return it straight into a struct. So all of these values, ones that have been changed or whatnot, all of the methods that we've got, everything can be saved with these two functions right here, JSON stringify and JSON parse. By default, I'm looking at Antonis's next question, is that it is unencrypted and it is able to read. Now, there is a JSON encode, which is for DS maps. So I'm not totally sure what the best way to be would be to encode your actual struct that you're saving there. Someone in the chat might have a better answer for that. By default, yes, it is saved in just a JSON file that is plain text. You could potentially change it outside of the game if you wanted to, but I wouldn't recommend it. But yeah, that's a really great way to save and load. And a really big benefit when it comes to structs is that you can just do that instantly. Okay, last thing we're going to talk about is going to be constructors. This is where everything kind of comes together. So constructors, this itself is a new keyword in GameMaker. And the reason for that is when we use a constructor, we actually need a special way to create it, which is going to be using the new keyword because we actually are creating a new struct. A constructor is just a template for making a struct. But the powerful thing about constructors is that it allows us to use inheritance and kind of function overloading. And if that doesn't mean anything to you, then don't worry about it. But let's take a look at an example of a constructor. So let's go back into our structs script, which actually shouldn't even be named structs, but we're not going to worry about that right now. This is going to be our constructor. So this is how you create a new constructor. You give it a name, or you say function, and I'm going to call this animal. So it's a function just like this, but then we use the keyword constructor, and we open this up like this. This is a constructor, which is a template. It's a building block for your struct. It allows us to make a new struct with all the data we might want inside of it. Now, the reason I'm going here and saying animal instead of cow when I've spent so much time talking about cows is that constructors allow us to use inheritance just like we already have when it comes to parents and children in GameMaker. But it allows us to share data inside of our structs and share the methods in there. Now, this syntax reverts back to normal syntax. So if I wanted to create a name, this is the syntax I would use. It's no longer a struct syntax. It is just normal equal sign, semicolon, you're good to go. And you can have your own functions inside of here. And we can set these. And this is an example of a very simple animal constructor. Now, the inheritance comes in when we want to do something like we want to go as abstract as possible. This is really great for games that have layers and objects that are related, but you want them to be unique in their own operating. So if you have a game where you have an item or an enemy, and you have a master enemy, but then you have children of those enemies that you want to share some things. Kind of like how when we do objects, you can absolutely have children inside of there and share events and share code that way. You can do the same thing when it comes to constructors, but these work the same way as structs do. So let's take a look at this. If I wanted to create a cow specifically, I could say function cow, use a colon to indicate that it is inheriting from animal. This is its own constructor. And now this cow will return a struct when I make it, but it will have this property and this method inside of there. But what's really, really cool, I think the best and most powerful thing about these constructors in the first place is that if we want this to have its own functionality when it comes to this method, we can come in and we can create this ourselves. So let's say we created a cow, but we wanted this cow's method of set name to do something different. Let's say we wanted to actually return the new name, or we wanted to, let's say, return name plus new name. So this is a different function. It's the same name, but now every cow you create when you call that method is going to do this. But if you create an animal, let's say we wanted to make a chicken and we made another thing, it could do something and totally different. So when you start thinking about this as abstract as you can, you'd want to have items and enemies and animals in your game that you can just say, hey, go do this. And if you're a chicken, you want to fly there. And if you're a cow, you want to waddle there. And if you're a dragon, you're going to blaze a path of destruction along the way. But it's the same method. You can even pass in the same arguments, but they're going to react appropriately. This allows us to have so much power when it comes to inheriting methods among our structs. Now, how do we actually create that? Well, we created a struct like this with saying the struct name equals and brackets. And if we wanted to create from a constructor, we would say variable name equals, and we have to use the keyword new. This is where it gets a little different. We have to say new, and then we call that function name. And this is now a struct that we created from cow. So it returns a struct with all the data that we have inside of here, all of this data. And then if we overwrote it, this is now the data that we have. But the constructor returns a struct. It is just a template for making them, which is why we covered it last. Because once you understand what a struct is, which is a way to hold data in a variable, and once you understand what a method is, which is just a way to hold a function in a variable, a constructor is just a way to create a struct on the fly like this, having all the data that we already want inside of it. And you can also just do the same thing for an animal. Now we have a cow, we have an animal, and if I called my cow dot set name, this would actually return to us the name that's already in there plus the name that we set. So that's what that would do. But if we called my animal dot set name, well, we said that this would actually set the new name for us right there. Because these are both structs, they both have the same method name, but we have taken one and told it what to do. So this idea here is that the more abstract you go, the more powerful your game can get. And in my opinion, you have to balance that. So we could go as abstract as we wanted to in a big game. We could have you could even go one up from this if we wanted to have a creature, because you can actually have multiple inheritance. So if we wanted to have a creature here, you could, and then animal could inherit from creature, and then cow is inheriting from animal, which also inherits from creature, and so on and so forth. So, when you're making your game, you now have a ton of power and a ton of flexibility in how you want to do that with structs, methods, and constructors. What I encourage you is to not get paralyzed with all the options that are available out there. Don't try to make the perfect code with GML so that your game can scale to infinity. Instead, take what makes sense: structs, arrays, DS maps, whatever it is. Take what makes sense and use that in your project to create something, because that's the whole point. There's no reason to spend all day learning these awesome GML features if you don't actually use them. So use what you can, learn what you can, and just make the best game possible. Let's go back to Q&A and we'll talk about constructors if anybody has questions there, or just any questions in general. So we'll go back here. Would you use structs and constructs to hold things like in-game player info, asks Tevin. You absolutely could. Yeah. Uh, if I had a game where we had multiple players, like if you had NPCs, if you had multiple players you could choose from in a game, yeah, I would use a struct to hold all of that information because it would be super easy to switch between them. Imagine you've got three different playable characters and you have a constructor that is player, and then each of those unique players that you can be as would inherit from player. And so if the player swapped between player A and B, your code wouldn't even need to change necessarily. You could still call move and attack and run and open inventory, but you could have those methods do entirely different things based on that player, and then you could save and load that no problem at all. Joseph asks, can you call parent structs method if you have replaced it in an inherited struct? From my understanding, no, but that is a really great and in-depth question. So if one of the GameMaker supporters can answer that. Mark asks, can you pass initialization params to the constructor? And yes, you can. So if we wanted this animal to have a name, so this says we've got a name inside of here, you can absolutely do that. So we could replace our name with what we're passing in right there. And now when we created it, when we make an animal, we would have to do that. As for the specifics of inheriting from this to cow, well, let me actually show you what I'm doing. Might help a little bit. So yes, you can take an argument and put it into a constructor just like I've done right here. So when you create an animal, you have to now pass in name. So if we come over here, this animal needs a name of Sozin. So that now needs that. Now, when it comes to inheriting this, that's a question that I am not 100% sure on. This cow inherits from animal, which requires this, but we're not saying that this does. And the order that things get created in are a little bit different than you might expect when it comes to constructors. So let's see if any of the support staff on GameMaker know the specific answer to that, because that's a really great question. We've got another question that says, are there some data storing techniques more efficient than CSV/JSON? Mm. JSON is actually incredibly efficient, if that's what you're referring to, just specifically efficiency. If you use, I believe you're going to want to use JSON, and buffers are going to be the most efficient method of saving and loading data. Now, when it comes to efficiency and saving and loading, that's usually not like the most important thing. So I guess that just depends on what you're looking for. But yes, I mean, that method is one of the most efficient. C asks, Can structs have private and public properties? So this is coming from an object-oriented language like C sharp, C++, something like that. And I believe the answer would be no. Now, I don't know what GameMaker is planning for the future. I'd be surprised if they added that because that's really moving into object oriented. But what they can do, which we haven't talked about specifically, is you can have the static property when it comes to variables. So a static property allows you to set something, and every time it's constructed, it only gets set once. So let's say we only want to initialize this variable called animals to 0 the very first time we call it. And every time after that, we could then increase it, but this would only ever get called one time. So static is something that you can do, but public and private, I do not believe is something that we have access to or will. Kellen asks, how does struct inheritance work with constructor arguments? And that is a really great question, and I need to play around with it more. So on a first level, you can pass in anything you want. So when we were looking at the first level of constructors, it's just a function. You can pass in anything you want inside of there. And these can also be optional. So if you don't pass anything in, then it gets set to this. If you do, then it gets overridden to that. So you can have functions in there. But then where this comes into play here is something that I am not 100% sure on. All right, last question that we'll do here, and then we're going to wrap this up. Thank you so much for joining, everybody. Mark asks, can you put script logic inside the constructor or just variable declarations? So, Mark, what do you mean specifically by script logic? Are you talking about, actually, I'm not even sure. Are you talking about like a runtime function inside of here? When you say script logic, what do you mean? Well, if he gets around to answering that, then I'll see if I can answer it. But thank you very much for joining, everybody. I hope this has been helpful. I hope you've learned to love cows as much as I have, and that you were able to learn something about GameMaker language that you didn't know before, because it's really, really awesome. And I love the cow emojis. That is fantastic. So Mark replies, say if foo name equals foo else. Oh, gotcha. Okay. So what Mark is kind of asking is, can, like, for the optional argument, which I kind of just showed here, this is, yes, you can put the script kind of logic inside of here. You can have optional arguments in constructors, as far as I'm aware, which means that for this variable anything, if you don't pass anything in, then it will equal anything. But if you do, then it's going to equal that. Otherwise, you can come in and you can make just a, in the constructor, you could say something like if anything is equal to undefined, then yeah, you can do something like that inside of here. That I believe is totally fine. So thank you so much, everyone, for joining, and we'll see you guys in the future. As I like to say, keep making, keep learning, and I'll talk to you later.